Welcome to Kevin's Classroom. It's great to have you. I hope that during the next few sessions that you get to know my style of doing things. I try and keep it simple, as you maybe have seen on some of the others you've looked at. But what I'm trying to achieve a recipe that you can remember and go through a process of understanding how these things break down, the types of problems that you're going to encounter, and essentially, as I've said before, if you can bake a cake, if you can follow a recipe and remember it, that's essentially what the chemistry and physics is about, with a little smattering of mathematics thrown in here and there. Let's look at, first of all, some of the bugbears that really get quite a few students hot under the collar because of silly mistakes. Unfortunately, in many cases, many of the students coming into, especially now in grade 10, the basics that they dealt with way back have been forgotten or perhaps not adequately covered. And there's a few little things. The most basic of all is, how do we convert liters to decimeters cubed, to milliliters, milliliters to deciliters or decimeters cubed, kilograms to grams, grams to milligrams, and a few other units that we're going to see, such as micro and nano, which come into specifically physics, but in chemistry as well to a degree. But now, let's first of all look at conversions of things, right? Now, I've got a system that I've used, and I call it, I've got like a little mountain over here. Let me just draw it so that we can start and have a look at it, okay? And I call it Kilimanjaro because the top is kilo, all right? Now, what we've got to remember is we've got to remember going down from kilo all the way down, because the kilo is the prefix in front. I know that in many cases this is really very simple, but you'd be surprised how many students get flummoxed by this. So we've got, let's say at the top here, we've got kilo, right? And at the bottom, you know that we've got milli, right? Now, how do we remember? Okay, how do we remember basically what order to follow? Well, there's a way of doing it. And the way that we do it is we say, right, there's many out there that you've no doubt heard of before, but essentially there's a little mnemonic. Let's just move this up a little bit so that I can write it down. Okay, and basically what it says is this: King Henry died a miserable death called measles. All right? Now let's just have a look here. I'm just going to change that to red. What we've got here is KHDMDCM. King Henry died a miserable death called measles. Some of you may in English be doing one of the King Henry plays by Shakespeare, etc. Ancient King of England. I don't know if he really was one. I guess he was, because there was a King Henry VIII. But just some hook to remember it by. And believe me, a lot of people actually use these. It's not childish at all. Because it just makes it a better, quicker way to remember it. Because when you're under pressure, you want to be able to rattle it off. King Henry died a miserable death called measles. Write it down and then take it from there. Now, why did we remember this? Because if you look, the letter at the front, KHDMDCM, we actually are going to use it as a way of telling us how to write this, right? King Henry died a miserable death called measles. And there's milli, centi, deci. This I'm going to just call meter here. And this is deca, hecto, and kilo, right? So that's the essential, the beginning of the framework. Now, let's just say to ourselves, well, hold on. What are we going to be converting? I just want to erase this one quickly. We're going to be converting units. So first of all, we're going to be converting a unit of length, right? A single line, a piece of string. we're going to have to measure it and change its dimensions to centimeters, to millimeters, to decimeters, to kilometers, to whatever we like. Okay? We need to be able to work out how to do that. So I'm just going to put up here, we've got length. Right? The next section is we're going to take a length and a length, correct? Which essentially is an area, isn't it? And the last one that we're going to do is we're going to do a volume. Right? Why? Well, because we want to measure things like this. Right? When we're talking about chemistry, we want to know how much gas can fit in here, how much liquid can fit in here, because we're going to be working with those. Right? So let us just see how we're going to start off with this. Can you see kilo aligns with the top and milli aligns with the bottom? Okay? Now, let's just first look at length, a single unit. How do we convert that? Well, what we say is that each jump is a factor of 10. All right? I'm not going to put in times. Let me just remove that. Okay? All I'm going to do is I'm going to put each jump is 10. Because what's important if we're going up or we're going down? All right? That's the key to this. The area is a factor of 100 each jump. Why? Well, I'll tell you now. The factor of 1,000 is the volume. Why? Well, because let's look at this. Okay? The length of the side here, we measure in, it's a single unit. Meters, centimeters, whatever you decide to measure it in. But if you want to convert it, you're only converting a single figure, a single unit figure over there. So if you want to convert millimeters to centimeters, right, there's a factor of 10 between each one. If we're going to convert milli to deci, there's 2 jumps, which is a factor of 10 and another 10. So it's going to be 100 between them. Okay? Area is made up of 2 individual lengths. So we have to account for the factor of 10 there and the factor of 10 over there. Right? Because we've got 2 lengths, there's a factor to multiply or divide by 10 there and another one of 10 there. Now if we look at volume, I hope you can see that clearly. You've got length there, a length there, and a length there. So there's 3 lengths that we are going to have to convert. That is where we get the 1,000 from each jump, right? So every time we have a jump, all right, we've got a factor of 100 for area and 1,000 for volume, right? Now, how does this Kilimanjaro of mine work? Actually, very simple. You say to yourself, right, let us say they give us 25, let's just do an example, right? Let's say they give us 25,000 cubic centimeters. And they want us to convert to meters cubed. What do we do? Right. This is what is given over here. Given. So this is where we enter the table. All right. Let's just go up. We're going to enter it over here at the centi level because we're given centimeters cubed. So we enter at centi and we're on volume. So this is where we are. Where do we want to get off? We want to get off the mountain when we get to meters cubed. So we're going to go all the way up to there. So we say we're going 1, 2 steps. Okay? The first thing we say is we're entering at this point and we are going upslope. Right? Upslope, it's getting smaller. The mountain's getting narrower. What do we do to make something smaller? We divide. Right? So if we're going up this King Henry scale, we are going to divide. And we say how many steps? Well, we've gone up 2 steps and we're volume, so each is 1,000. So we're going to say that's going to be 25,000 divided by 1,000. That's the first step. And another 1,000 is the second step. Okay? Obviously, the other way around, we'll do one in a few moments, is going to be, we're going to go down slope, and if we go down slope, we multiply. Why? Because, quite simple, we are getting bigger. The mountain is getting wider. So from kilo at the top down to milli at the bottom, we're getting bigger. Bigger, multiply. Going from milli to kilo, we're getting smaller, therefore we divide. It's as simple as that. Okay? So we start off by saying, where are we and where are we going? We count the steps in between, noting if we're doing length, area, or volume, and all we've got to remember is 10, 100, 1,000. Okay? Let's do another example just quickly. Let's say we've got, I don't know, 0.0005 square kilometers. Well, let's add in another 0 or 2. Okay, no, let's leave it like that, all right? And let's say we want to know how many square meters is that. Okay. Well, what do? Well, we enter, okay, we enter at kilo, right? We enter here, there we are. We're on the area, so we are there. And we are going down to here, right? So we are going 1, 2, 3 steps. Can you see that? Kilo to hecto, hecto to deca, deca to meter. So we're going down 3 steps. We're going down, so we multiply, right? We say we are going to be 0.0005 times 100, because it's area now, times 100 times 100, right? And now in this case, right, it's entirely up to you whether you use a calculator or whether you do it by the old method of, well, I've got to move it 2 for that, 2 for that, well, 2 for that, 1, 2, 1, 2, and then another 2, right? So you would say 0.00305 times 100, that's my first one, times 100 again, which gives us 500 square meters, right? So let's recap, what do we do with this? The first thing we do is we say, where are we? We remember King Henry died a miserable death called measles. Okay? That gives us our kilo, hectare, deca, meter. It's also going to be a liter or a gram. The same applies to liters and grams. So where we've got our M for miserable, please add in over there the liter or gram, because they fit in at that point as well. Deciliter, milliliters, centiliters, particularly in chemistry, we're going to deal with those. And kilograms, we're going to deal with that in force when we talk about those issues. Okay? So what we've got here is we've got a situation where we have to remember that. Then we say length is a 10, area is 100, volume is 1,000. Each step, we go where we start. We're starting at centi. Say, for example, we're starting at centi. If we're going upslope, it's getting smaller. We divide to make something smaller. And we divide by how many slopes, either times 10, 100, or 1,000. Okay? Right. Now, that's basically just looking at conversions, okay? When we get into the actual, the units, the sessions, the lecture sessions themselves, this is the kind of thing we're going to be working more and more with. So when I talk about it, you've seen it before. Hopefully you'll do a little bit of practice on it, which is well worth it, okay, without a doubt, okay? So just on a conversion basis, those are the things to look at, okay? The initial session that we're going to deal with when we start off with the actual modules themselves is we're going to start dealing with The definition of units, mass, force, pressure, viscosity, and various things. They're just the stuff at the beginning that we need to know what they are, how they're measured. Okay? Because everything that we do, we're going to be measuring in terms of meters, seconds, kilograms. Right? Everything's got to be in those units. I know we talk about kilometers per hour, but in physics, as you'll see, we always convert it to meters per second. Everything is those base units, right? And just before we sign this one off, what the key to all of it, and you'll hear me say it again and again and again, is when you're looking at a problem, you'll see in it the recipe that we're going to use to solve it. But at the same time, I can't overemphasize, draw it. No, don't take out a protractor yet and compasses. And draw a little sketch that suits you. Draw your truck. Draw the skier. Draw the things that are happening. If it's falling off a building, we draw the falling off a building. Okay? We try and conceptualize because that actually is the key to success with particularly physics. Okay? Chemistry is slightly different. We'll show you the recipes for that. But the physics side, we need to draw it. Okay? So, as I say, in the next session, which is going to really be session 1 of the lecture series, we're going to be attacking the basic measurement units of grade 10. Not only grade 10, but grade 10, grade 11, grade 12, even university physics. That ain't going to change. We're just going to keep meeting new characters, like I said, guys like nanometers, picofarads, and things like that. That comes much later on. Okay. And I'm looking forward to it. Remember, one of the keys of each session is, as you're going through it, if you don't know, just stop, make the notes of the recipes as we go through. Eventually, I'm going to summarize, and you'll see what will be coming will be exam or test preparations, where I'm going to focus on 99% of it is questions. Not the theory as much or multiple choice, but how to answer the actual questions themselves. Using maths, using the physics formulas, using the drawings, etc., the chemistry the same, right? That's going to be the exam preparation side. There'll be questions there that you download and we'll work through the answers in it. However, in order to get the best out of all of these series, if it's physics, chemistry, mathematics, not as much, but in essence there are recipes there that we're going to bring into play. So what you need to do is you need to go through them at a pace that suits you. Make the notes. As I'm talking about the recipes, make the notes of the recipes. I repeat them a lot. And then when we're going through, stay with me on the calculations. As you know, you can stop it, and then you can do the calculation, and then we can move forward. I'm looking forward to it, and I hope you are. Thanks for joining me.